what we have done so far is we have taken the maximum shear and compared it with a particular constant for the material, yield shear or some constant, and we said, okay, if this is met, yielding occurs. Okay, that's how we wrote this sigma is equal to tau max minus kappa equal to 0, right? This was due to Tresca. If it were von Mises, we said RMS of tau max, right?
Yeah.
Minus kappa is equal to 0. Okay, so this kappa, I can call this as T, which is Tresca condition, and this is von Mises condition. Make sure that these two are not the same. You have to understand that these two are not the same.
Yes, sir.
Okay.
Yes, sir.
Now, not all materials, and these are materials that yield by shear primarily. Correct? Right? Another statement for this is they are pressure independent. Banu.
Yes, sir. Hydro.
Okay. For example, if I take a scenario where I have the stress to be something like this, let us say I have a hydrostatic pressure like this. And I keep increasing P. When will it yield? Let's say it is dependent on any one of these.
Yeah. It will never yield.
It will never yield.
Yield, yeah. Because the pressure is same in all.
That's because the shear stress is 0.
Yes, sir.
Correct?
Yes, sir.
This is usually true for most metals. If you go back to my book, I would also told you that people did the experiment and found that for very heavy pressures, there was no yielding occurring. Okay. Unless you went to a particular state where the stress state matched the bonding stress. Okay. Supposing I have a material, let's take concrete. Okay. I pull it, let's say, to failure. I'm going to call this a sigma T, which is tensile stress that I've applied. And let's say this failed when it went to a failure stress value. Okay. I'm going to call this as sigma TF because I conducted a tension test. Now, I do the similar test, but right now I do the other way. I do a compression test. In this case, the compressive stress going to a value which is not the same as this is what you will see in the experiment. That is, sigma TF is not equal to sigma CF. Are you able to understand this?
Yes, sir. Yes,
Yes,
sir.
sir.
Right? In this scenario, I want you to ask if this meets the pressure independence independence condition? Does it meet the pressure independence condition? Is my question clear?
Sir, can you
Shall
come
I-
again once, sir?
Okay. So I am now testing a material. This material, I'm testing in tension first. In tension, this is a tensile test. I found the condition for failure to be sigma TF. This is the value I got when I did the tension test. And I take the same material, I did the compression test. Okay. I get a value which is sigma CF, but that is not equal to sigma TF. Under such condition, will it meet the condition that the pressure independence is met?
The pressure
No, sir.
independence,
That is,
the condition.
will yielding depend only on shear? Question is better understood now?
Yes, sir.
Yes, sir.
Okay. I want you to probe into this and tell me.
Sir, but this
No.
I conducted these two tests and I found that there is a yielding or failure to compression seems to be different from tension. One of the examples is concrete, the other could be, let us say, a soil sample.
sir,
Yes, sir.
but this is not hydrostatic loading, right?
So my question is, in this kind of material, can I make
Okay.
an assumption that yielding depends only on the shear? That's the question. You have understood the
So we
question
can't,
properly now?
Yes, sir.
we
Yes,
can't
sir.
say that if it were depending on shear only, then both
Okay.
must have been
So
same,
I'm going to
because
give you time.
with
Go
change
through,
in direction, there is
try
no change in
this,
direction.
and tell me whether I can find a yielding criterion which depends only on shear. Okay. Then we'll come back to it.
Can I make
Who is speaking? There's a lull.
Sir, here, sir, can we say that there is cross coupling between the properties in longitudinal direction and transverse direction?
What is longitudinal? What is transfer? These are actual tests. Both are axial tests.
Oh, both are axial. Okay.
Both are axial tests. No, this is just compression. This is tension. That's all.
Yeah, but sir, as we know from the structure, I mean, concrete technology, that concrete is, sir, I mean, strong in compression than and weak in tension, right, sir?
Yeah, that I know. But my question is different. My question is, now, does it translate into this question? Does it translate into saying that yielding is no more dependent only on shear? Good. Question is clear now, right?
Yes, sir. Yes, sir.
Yes, sir.
I
Sir,
want an answer from you when we
sir, if
start
we
the
look,
next class.
sir, can I say something?
Hmm.
Sir, in soil in geotechnical engineering, we do some triaxial test, right?
Yes.
So in that also, sir, just like we make the confinement and we apply the stress, so the failure will occur at means yield will occur at some point.
Yeah,
So is it kind
we
of
apply a pressure condition,
yes, sir?
and we do either tensile or compressive test.
Yes, sir.
I understand that. That's why I'm saying
So
it doesn't matter. Let's say these are the two materials. This is the material for which this is the same material. I'm using this material for both tension and compression, and I'm getting two different results for compression and tension.
yes, sir.
Is my yielding condition, which depends on shear only, enough or not? That's the question. Got it?
Yes, sir. Yes, sir. That's I got it. That I got it.
Right? I
Yes,
want
sir,
you to
that I
think
got
about it, so that when we meet next, we will discuss this more.
okay, sir.
I would urge every one of you to try all the problems.
Yes, sure, sir.
If you don't get the problem, all you have to do is take your phone, call the person who is responsible for it. The other person who is responsible for it should be able to explain to you.
Yes, sure, sir.
Okay.
Clear?
Yes, sir. Yes.
So that in the next class, I can ask any one of you to solve any one of the problems.
Okay, sir.
How about that?
Fine, sir.
Fine.
Sure, sir.
Sure,
At
sir.
least that way you will interact.
Yes, sir. Yes, sir. Sir, one is doubt I have, sir. That ninth or some 10th problem in that we are putting some aluminum cylinder in a rigid steel cylinder.
Hmm.
So the aluminum cylinder is solid, and we are putting it as a piston in another rigid steel cylinder, and we are applying some axial pressure on that. So
No,
so
axial
there is
force that creates pressure. Yeah.
yeah. So sir, my doubt is, sir, how the failure will occur, because there will be confinement, rigid confinement from both the sides.
Ask Pragyan. Pragyan is solving that. Correct?
Yes, sir.
Yeah. You have his number. Talk to him. Find out. The reason why I'm saying this is that that way at least you people can discuss among yourselves. Some of you have submitted, right? You can also ask whether how you're doing your problem is correct or not.
In the question which you asked, sir, in that, do you want to know if there can be a method to make it depend on
Don't
only
know.
shear, or
Don't know.
will it depend on shear?
First question that we have to ask is, can I have a yield condition that depends only on pure shear?
Okay.
And then I can promote that question to the next stage. But first, I have to ask that question and answer it properly.
All right.
Okay, Aditya?
Yes, sir. Yes.
Yeah, answer may be simple, but I want you to think about it.